and 17. Number 12 over there. What method? What method would work best for this?
Addition.
I think addition, right? With the addition method, you need opposites. Well, right here I have opposites. So I'm going to use the addition method. I have 8x squared plus another 8x squared. That's 16x squared. A positive y squared, and I add to it a negative y squared. What happens to those? Drops out. And on the other side, 9 and 5 is 4. Carry the 1. Looks like 64. Right?
Yeah.
If we want to get x squared alone, divide by 16. Ooh, solid. X squared. X squared is 4. And then square root, square root. Don't forget though, when you take the square root, what do you have to take? Both the positive and the negative. So you actually get 2 values for x, right? Are we done there? No. We need to get the y's that go with it. So I have x equals 2, and I have x equals negative 2. I need the y that goes with it. That means I'm going to need to plug into one of these two, right? Which one?
Top.
Top? Yeah. Top sounds good to me. 8x squared plus y squared is 25. 8x squared plus y squared is 25. 8x squared plus y squared is 25. But what is my x this time?
2.
2. And please remember the order of operations. Please excuse my dear Aunt Sally. So exponents first, you have to do the 2 squared first. That's 4. And after you do the exponent, then you can multiply. 32 plus y squared is 25. How do you get the y squared by itself?
Subtract 32 from both sides.
Subtract 32. And when you do that, you get y squared equals
-7.
negative 7.
It's no good.
Why is it no good?
Because you can't square it.
Yeah, you can't have the square root of a negative. Well, you could, except the directions say find the real solutions, right? This isn't going to be a real solution. It's going to be an imaginary solution. So this one, you throw it out. When x equals 2, you don't get any y to go with it. So there's no solution there. Our only hope is over here. 8x squared plus y squared. Only this time x is
-2.
square it first, you get 4. And you probably can tell, well, this is going to be 32 again. And guess what? If you subtract 32, what's going to happen?
-7.
Yep, same thing. Y squared equals -7. And again, because the directions tell us has to be a real solution, this is going to be imaginary, so we throw it out. When x is -2, we also don't get any real solutions. Right?
Yeah.
So, although we get some x values, there are no y values to put with it. So what's the answer for 12 then?
No solution.
No solution. And then 17 also seemed to be a problem. 17 seemed to be a problem. Probably not going to graph it.
Probably not.
Probably not going to graph it. And you can't use the addition method. I've got a square in first power. I've got a y squared and a y. You can't put those together since they're not like terms. So that only leaves one option. Substitution. And I'm probably going to start with this one down here. I don't think it really matters a whole lot if you get x by itself or y by itself. Oops, I want to get rid of the 6 first, I think. So xy equals -6. And then you can either divide by x or divide by y, doesn't really matter. X equals -6 over y. And what will we do with that?
Plug it in.
Plug it in, plug it in. So we're going to take the x squared plus y squared equals 13, and we're going to plug that in for the x right there. We're going to plug it in for the x. So I have -6 over y. There's my x squared plus y squared equals 13. When I square that fraction, remember you have to square the top, square the bottom. What is -6 squared?
36.
And on the bottom you get a y squared plus y squared equals 13. Do you mind if I put a 1 under there and a 1 under there?
Yep.
Now, hopefully you remember back a chapter or two ago, when you have fractions in the denominator and you don't like fractions in the denominator, you can get rid of those fractions in the denominator. You have to multiply every term by what the common denominator would be. What would the common denominator be? Y squared. So we're going to multiply both sides by y squared over 1.
That's so smart.
When you do that, here, 36y squared over y squared plus, what's y squared times y squared? Over 1 equals, other side, 13y squared over 1. And only one fraction will have things that cancel. And what does that give you then? 36 plus equals, and if I were you, I think I would get it all equal to 0. I would minus 13y squared. And on the left side, I think I'm going to rearrange those. Y to the 4th minus 13y squared plus 36 equals 0. Now you should be able to factor it.
Yeah.
Now you should be able to. Y to the 4th, that's going to just be y squared and y squared. I need something that multiplies to 36 and adds to 13. 4 and 9, signs,
Both negative.
-9, -4. Now, I've got y squared still. You can factor them again. This y squared minus 9 can be factored. What does it factor into?
Y plus minus.
3 and 3, and what, Darius?
Plus and minus.
Yeah. Same thing with the y squared minus 4. That can be factored into y and y, 2 and 2, plus and minus. Oh, question?
Yeah, is it okay if we don't do that? But don't factor.
Well, you're going to get the same plus and minus as, yeah,
When you square it.
right.
Okay.
Well, the important thing is then, how many values of y are you going to get? Y plus 3 equals 0, and you get y minus 3 equals 0, and you get y plus 2 equals 0, and you get add 2, there's my first y. Minus 2, there's my second y. Add 3, and minus 3. Are we done?
No.
Why not?
X.
You gotta find the x's that go with it. But the good thing is, it's pretty easy. X equals negative 6 over y. X equals negative 6 over y. So negative 6 over negative 3. What is negative 6 over negative 3? So x is 2, y is negative 3. I would like you to write it like that. Yeah, oh, right. If you wrote it like this, I would like that too. I want to be able to see what x and y go together. So next one, x equals negative 6 over y, x equals negative 6 over, x equals negative 2 when y is 3. Next, x equals negative 6 over y. Over negative 2. So what do we get? X is 3 when y is negative 2. X equals negative 6 over y, only one more, over 2. Negative 3 when y is 2. So you actually get 4 separate solutions for this one. Makes up for the one down there where it was no solution, right? Oh, I'm exhausted after all of that. I know I did. No wonder I have a bad shoulder. No wonder I have a pinched nerve back there, or whatever it is. Anybody with questions? We're going to do a few more today, just for fun. A few more just for fun, Jack. Yes.
We get the assignment.
Oh, yeah. You got to leave too?
Yeah.
You're not even in track.
He is. He's a
He's
thrower.
not. He's a thrower. A thrower.
He's our points in that department. We need him. Yeah, I'm the only one. Braden.
I got number 1, 2, 8, 10, 16. 1, 2, 8, 10, 16. Right there. Good luck. It's not sounding promising.
Yeah, I know. I've been saying that all day and just getting lost out of it.
Well, as long as it doesn't lightning, you should be good.
Yeah.